Hopefully everyone can hear me and can see the screen, and we shall make a start. So firstly, I want to thank everyone. That's the most important thing of all of these sessions, to thank you for taking time to come along, to take time out of your busy days, mornings, evenings, to share knowledge with each other and to find out a little more about the testing world. So in this session, I want to talk about something that's changing how we build software. Not just how we write the code, but of course, how we test it. And that's AI coding assistants, which are rapidly becoming part of that development workflow. And that raises an interesting question for the testing community. When the code is written by an agent, how do we make sure that it's actually trustworthy? So before we get into that, very quick introduction, because we have got a lot to get through here. So as you can see, I'm Rob Cowell. I do work at Salesforce, but I'm not going to be talking about a single thing that is Salesforce specific here. I want to kind of strip things back to the fundamentals of how we tackle code and output that's generated from these AI testing agents. So before I worked at Salesforce, I was a DevOps advocate covering the full range of the DevOps lifecycle. So of course, testing and QA was included in that. And a lot before that, I was an architect and a developer for a number of years. So I've been in the trenches, experiencing writing code, writing tests, and managing that quality. So let's start things off with a bit of a simple question. If AI is writing our code, what exactly are our tests validating? Now, for decades, the model of software development has been pretty consistent. Humans wrote the code, tests verified that the code worked correctly, and over time, that's how we built confidence in our systems. But that relationship's starting to shift. So if we look at that classic model, it looked a little something like this. A developer writes the code, tests validate that code, and if those tests pass consistently, we've got that confidence that the system's behaving correctly. And this model's worked for a very long time, but it does assume something very important, that the developer fully understands the implementation that they produced. And usually they do. Developers are pretty smart folks, right? But now AI coding agents are changing that workflow. Developers are increasingly describing the intent of what they want the system to do, and the tool goes away and it generates that implementation. Now, sometimes that's a few lines, sometimes that's a whole function, and sometimes that's a whole module. There's even a name for what people have started using for this style of development, which is vibe coding. You describe the outcome you want, and the system fills in the details. So you give it the general vibe of what you want to output. Now, when humans write that code, the intent and the implementation are very tightly linked. The developer chooses the algorithm that they're going to implement, they decide the structure, they usually understand every branch and edge case that they've introduced. With AI-generated code, that relationship becomes a lot looser. The developer still provides that intent, but the implementation is produced by the model, which means that the resulting code may include logic that no one's explicitly designed. Sometimes that's helpful, sometimes it's a little surprising. Let me give you a simple example. Imagine asking an AI assistant to write a function that validates an email address. A human developer might write something simple, check for an @ verify the domain, maybe use a regular expression. Now, an AI system might generate something a little more elaborate. Multiple validation stages, extra defensive checks, several conditional branches. It might still work perfectly, but the developer reviewing the code might not fully understand every path through that logic that the AI is implemented, because the AI is using decisions based on its corpus of knowledge. It doesn't have that kind of human insight. We haven't quite got to that general intelligence model yet. So generated code typically introduces hidden paths, extra conditions, edge case handling, assumptions that are embedded in the training data. That's quite dangerous for us as a testing community. None of it's inherently wrong, but it does mean that there's behaviors that nobody on that team has consciously designed. And that's where testing becomes even more important than ever, because tests prove what the system actually does, not what we think it does or what we intended it to do. The key word of intend and intent will keep recurring here because that's how the AI models are designed to behave. And there's another factor here as well. AI is changing the speed of iteration on those releases, on those codes, on those changes. When developers write code manually, they usually change it incrementally. A few lines here, a little refactor there. But with AI generated code, that entire implementation can change very quickly. The developer tweaks the prompt and regenerates the function. Suddenly, that whole underlying implementation could be completely different. Same intent, different code. Now, in that world, tests become something extremely important. They become that contract that defines the correct behavior. If the implementation changes, but the tests still pass, you could say that the system is still behaving correctly. That means that developers are free to regenerate those implementations, to refactor far more aggressively, or even replace large sections of code, as long as the tests still define what that expected behavior is, as long as the contract remains fulfilled. Now, there's an obvious next step in this story. If AI can generate the code, and AI can also generate the tests, then eventually we arrive at another question, and it's a very important one. If AI writes the tests too, who tests the tester? Or to borrow from a much older phrase, who watches the watchman? Because if the same system writes both sides, we may have introduced a new risk here. The risk isn't malicious behavior, it's accidental agreement. The code generator, sorry, just a pause. I've just seen Robin put that one out in Latin. Hats off to you, sir. But it's absolutely right. It's, if you have the code generator and the test generator, they might be sharing those same assumptions. They might miss some edge cases. They might validate the same incorrect interpretation of the requirements. This would be like, in some ways, having the developer do all their tests themselves. Now, a good developer should do an initial test pass to check that it's fit for deeper testing. But the challenge there is that developers typically will always follow the happy path because they know how to navigate through their tests. If the AI agent is doing the same thing, and that can still happen. Everything still looks green, the code compiles, the test passes, the pipeline succeeds, but the system could still be wrong. So one way to think about solving this is through independence. Instead of a single system writing both code and tests, we introduce two agents with different goals. A build agent, whose job is to implement those requirements, and a test agent, whose job is to challenge that implementation. The builder tries to succeed, and the tester tries to prove it wrong. This adversarial relationship is actually very similar to the relationship that developers and testers have always had. And I mean adversarial in a friendly and professional way. We're certainly not expecting fights in the office here. Please don't misunderstand that. But some of you might have heard of an AI concept called generative adversarial networks. The idea behind this principle is that one agent is the creator, the other agent is called the discriminator. And if you think about it in terms of image generation, one of the most popular implementations of this is one AI generates human looking faces, trying to look like a photograph, right? Trying to be as realistic as possible. The other agent is trying to catch it out and prove it wrong. Over time, this back and forth is like, I got caught, I need to tweak this. means that you effectively get increasing quality to the point where the generator can outsmart the discriminator. If you want to put this in practice, I can't remember the exact name, but I think it's something similar to thispersondoesnotexist.com. If you have a Google for that, I'm sure you'll find it. Super interesting. But the point I'm making is that we can apply that same principle to our testing. Can we get the code to be of a sufficient quality that it will pass through that discriminator of the testing? In our test agents, can we make them strong enough that we can catch the error around generated code and make sure that we actually have that quality gateway implemented? If the testing agent is not independent and knows the tricks and the methods that the development agent has done, it's kind of biased and skewed as to how it approaches testing. Testing should be as clean room as possible. I saw earlier in the questions of Gandalf's session there, the question around how do we get to a point where we are not having to sort of go and ask the developer how to test things. Right? We should never be doing that. We should be fundamentally requirement-based, objective-based, outcome-based. Okay, those business-driven factors. Okay, and be independent of the implementation. By having separate agents, we can achieve that. Because a good testing agent, a good adversarial testing agent, as I like to think of it, doesn't just confirm the happy path. It tries to break the system. It generates unusual inputs. It probes those boundary conditions. It looks for hidden assumptions. It might fuzz some inputs. It might mutate the code to see if the test suite detects the change. In other words, it behaves like a skeptic. And that skepticism is super valuable. So what does this mean for your teams today? Well, there's a few practical strategies that can make a big difference. And they're not that different from the strategies that we as the testing and QA community have always used. So firstly, focus on behavioral testing. Tests should validate what the system does, not how the system does it, not how the code is structured, not the specific implementation. Secondly, invest in broad input coverage. Generated code will typically have far more branches and paths and directions than anybody had possibly planned. So varied inputs and a wide range of inputs are going to expose those paths. They're going to traverse those different directions through the code and make sure that there's nothing that really jumps out and goes into the wrong direction there. And thirdly, something that I hope we've all been doing anyway, maintain strong regression suites. Because when implementations can change, we talked about the rapid iteration, the velocity of change that AI coding enables, we need to make sure that our regression tests can protect the system from that accidental drift, making sure that we continue to focus on those outcomes. We talked when I was talking about rapid iteration, how with the enablement of AI, the prompt may be fairly similar, but the output of that prompt and the code changes that it makes can move incredibly quickly and incredibly differently. Huge swathes of code could potentially be changed. The underlying outcomes may remain the same. And that's why our regression suites need to be absolutely rock solid. So what is the real impact of all of this? Well, I think the biggest impact and the biggest takeaway that I will give you is that AI doesn't reduce the importance of testing. It actually increases that importance, because the more generative our development systems become, the more important it is to have really strong, reliable tests that anchor the behavior of the system. Testing effectively becomes the safety net for the experimentation. The promise of AI when it comes to development is, you can move faster, you can try new ideas, you can iterate, you can explore your wildest dreams. Things like Cursor or Lovable or any of the other AI generation tools, they certainly allow you to do that and to describe what you'd love to see, that app that you'd always dreamed of. Testing, as I said, is the safety net for that. It allows you to make sure that things are still meeting the objectives of your application or your business's application, your customers' needs, your managers' needs, however you want to define it in the space that you work. Testing is the foundation stone that makes sure that we're not building anything crazy, that it's stable, secure, and meets those objectives. So let's return to the question that we started off with at the beginning. If AI writes the code, what exactly are our tests validating? Well, they validate behavior. Okay, they're making sure that the code continues to behave in the way that we want it to. Well, if it's net new code, does it behave how the requirements came in? And to the question earlier about, how do we work in this space without having to go to the developer? You should not go to the developer. You should go to your business analyst or your customer and work out, what was the objective of this? What is the outcome? What is the job to be done that we're trying to solve? The tests also validate assumptions. Okay, assumptions are the most dangerous thing because when testing takes place, we want clarity, we want certainty, we want a very Boolean behavior. Does it work? Does it not work? Now, that can be at the macro level, very high level in terms of a business goal. But also when we start sort of drilling into the more detailed tests around a very modular thing and looking at different input, does it work when I put in a short string? Does it work when I put in a long string or a number? All these micro tests, we need to make sure that there are no assumptions at each of those levels. And testing will help us validate those assumptions. But we also then move into validating correctness under variation. And this is where, when I talked about, sort of a broad range of inputs, that comes into play. There's a whole sort of machine learning data science discipline around what they call fuzzing inputs. And the idea is you'll just randomly, within some constraints, like hitting it with inputs, trying different techniques, we can automate that type of behavior. So it's not just automating the test, it's automating the data that we use in those tests to preempt the unexpected inputs and the unexpected outcomes from those inputs. So again, testing will allow us to monitor and track that variation and make sure that things are correct in all of those scenarios. And increasingly, the net new piece that AI is bringing us now is check the generator itself. This comes back to who tests the tester, okay? But also who's testing the generator, who's testing the quality and the outputs and the deliverables that the automated AI code generation tools are doing. Because ultimately, when you're testing with code that's been generated from these vibe coding tools or from any other sort of semi-automated code generation, you want to have a degree of trust in the tool itself. You want to make sure that, if you get consistently failing tests, maybe it's not the developer. Maybe it's an issue with the prompts. Maybe they just need a little training or guidance and coaching on prompt generation, prompt engineering. Or maybe the underlying data set that your AI tool is not quite right. Particularly if you have a custom GPT or an AI model that you've kind of baselined yourself with your own data about your business, and that could be Agentforce, that could be a custom GPT. I know ChatGPT lets you do that. It could be a custom model that you've built out on Anthropic or any of the others. But you want to make sure that the tool is actually properly grounded in generating that quality code. Again, testing will come into its own here, be that manual or automated testing or AI generated testing. It's a chance to validate that the outputs that we're producing are not just correct for the business function, but the tools that we're using are validated as well. So there's a final thought that I will leave you with that. If the same agent is writing the code and writing the tests, we haven't automated that quality. We've automated the agreement. Real confidence is going to come from that independence. Developers optimize for success, human or AI. Testers, again, human or AI tools, or optimized for falsification, i.e. they're looking for mistakes. Okay, that's effectively what we're doing. We're making sure that nothing slips through that net. So in the age of AI generated software, the role of testing is super more important than ever, because the volume, the scale, and the throughput is bigger than it's ever been. Okay, so we equally need to skill up in the same way as the developers done, but we need to do it in a considered and controlled way that takes into account the differences, the type of things that we're going to be expected to tested in the AI development era. Now, I have seen a few questions coming in, so I have left a little time for questions there. So I will leave you with TestZeus's QR code there. But if there's any questions coming in on this session, I'll be happy to sort of see them from the hosting team and see if we can pick some of them off. Okay, when the generated code includes non-deterministic patterns or deviates from Salesforce best practice baselines. Okay, so how do we tackle those paths? Okay, perfect. So one of the things, this is where I will admittedly put my Salesforce hat back on, because non-deterministic code paths are a challenge. One of the things that Salesforce has introduced is the ability to have very fixed instructions in Agentforce Builder. So when you're building your agents, and this technique, I would imagine, would be applicable to other tools, but in the Salesforce context, when you want something that you need to be fixed, repeatable, and deterministic, you can bake that in with specific blocks in your Agentforce Builder that say, when you need to do this particular task, always do it in this way. Now, that might be always call this flow, always call this apex, always wrap things around those deterministic blocks. When you have the testing element of the non-deterministic blocks, to sort of come back from the question a little bit more, that's really where your testing agents should be robust. We talked about some of the techniques here, like input fuzzing, variation of inputs, making sure that we do the traditional things of testing singles versus bulks, trying to break the limits. Now, the automation tools, the AI tools, are going to be very good at generating those tests and generating those test data sets to cover lots of eventualities. Non-deterministic effectively means you're not going to get the same results every time, even for the simplest of tests. If it's an AI, you'll get the same test results. But if you think about how we generate things, you ask an AI tool something, it will tend to give you the same answer in different ways each time. So what I would suggest is, for testing in a non-deterministic way, test at scale, test lots of things, run the same tests a significant number of times, look for patterns. Patterns and pattern recognition is how we, in a non-deterministic world, get a degree of confidence. If we can see that, okay, it answers things differently, most times out of 10, but with that human in the loop of that interpretation, we can say, it's given me the right answer, just phrased differently, for example. That's a pattern, right? And the pattern is a pattern of consistency. So hopefully that's kind of covered your question there. Any more? In adversarial testing setups, how do you prevent AI-generated test agents from reinforcing correct assumptions in Salesforce business logic, especially in highly customized orgs. Yeah, that's an interesting one, and I think the key thing there is that they are adversarial, and that coming back to what we were saying earlier, they need to be very independent of each other. Okay, so assumptions in the code will be typically generated at that development, that build stage. If we have what I like to think of as a clean room test environment that doesn't see the how it was built and is actually testing for outcomes, for what's displayed, what's updated, what's deleted, whatever that test entails, but it doesn't actually have the even access to the implementation. And I know that's harder to achieve, but there's some very good tools to do that. Then those assumptions never get seen. Whether it's a developer assuming that an input will always be in a certain range, whether it's something in code comments, perhaps, making all of that invisible to your testing agent means that you have a scenario where none of those assumptions are taken forward. Okay, now I acknowledge that it's possible that the testing agent may generate its own assumptions in its own right, and that remains a challenge. And that's why I strongly encourage, with the power of automation and the speed of AI, being able to run those tests continually over and over again. Don't take a single test passing as a success. Take a batch of that same test as being successful. Okay, you see the patterns, you see the success rate. You get a threshold. It might be that because of agentic use, it might be that actually some tests will fail. Now, then you get into this existential question of, did the code fail or did the test fail? Because you've got two agents in this adversarial system. So always do these things at scale. Look for patterns, set a threshold. It's like, if I run this 100 times, my threshold, I'd like to set 90% threshold or a 95% threshold, wherever you have that degree of comfort, depending on the scope of your test, I would say is the sweet spot of managing that. AI just thinks faster than us and runs things faster than us, which allows us to act at that scale. What should exit criteria be when testing any AI agent? Because there'll be n number of scenarios or combinations to test. That is a super interesting one, and this again kind of leads to the concept of scaling. Right now, the way that question was worded suggests that the person asking the question has a degree of knowledge around statistics and whatnot, which I don't. However, I think again, I'm sorry to fall back on a previous answer a little bit here, but I think just scale and patterns are the way there. If we're looking at it through a little bit more of a statistical lens, then you want to sort of be anomaly tracking, okay? Not just in the anomalies in the test results, but anomalies in how many of those test results scaled out correctly. What is our hit rate on those? And then I think we can look for outliers. We can look at what's the average speed of code executing, what's the average success rate of test passing. What were the inputs and validations that failed for the ones that didn't? Are they outliers? Is it a result of us fuzzing those inputs? And actually in real world scenarios, would that have happened? I think the exit rate then comes down to, have we hit the threshold for, of 100 tests, did we hit, 95 plus passes? That becomes our success rate. And Robin, I'm guessing the link that you've posted there is a good article on, or a good tool on tackling some of those extended end-to-end tests. Okay, we are pretty much at time. So thank you everyone for your attention and great questions. I'm sure the team will be sharing more of those questions with me throughout the rest of the event, and I will try and get through as many of them as I can. Thank you very much.